All right, so on to homework number 20 over counting or combinatorics. Okay, so let's go ahead and jump in. So first and foremost, problems 1 through 6 on homework 20 will follow the slot argument idea. So let's go ahead and take a look what that is. So the first question we have, Pizza House offers 2 different salads, 5 different kinds of pizza, and 6 different desserts. How many different 3-course meals can we have? So the slot argument, I call it the slot argument because I make an empty slot for each course. So this first one would be for course 1, for course 2, and for course 3. And what I'm going to insert into the slots is the number of options I have for each course. So course 1, salad, I have 2 different salads, I have 5 different kinds of pizza, and I have 6 different kinds of desserts. So I've placed the number of options I have in each slot, again each slot for each course. And then I'm going to take these numbers and multiply to get the total number of options. 2 by 5 to give me 10, by 6 to give me 60. So I have 60 options. And the slot argument, yes, it really is that simple. Identify how many things you're choosing. So here we were choosing 3 things. Course 1, course 2, course 3. And then how many options for each of those things we're choosing, we fill in the slot. So moment of truth. Look at that, we got her. Oh, there we go. There's the proof. Okay, so let's jump to number 3. Again, problems 1 through 6 follow the slot style argument. Here we have license plate tags. So particular state to consist of 3 letters followed by 4 digits with repeated letters and digits allowed. How many different license plates can there be in this state? Okay, so we have 3 letters, 1, 2, 3, followed by 4 digits, 1, 2, 3, 4. So this has to be A through Z, A through Z, A through Z, 0 through 9, 0 through 9, 0 through 9, 0 through 9. So I have a slot constructed for each entry of that license plate. I have my 3 letters followed by 4 digits. So now we're going to fill in the slots with the number of options I have for each slot. So in slot number 1, recognize it could be any letter A through Z. So I have 26 options, 26 letters in the alphabet. For this next slot, so because repeats are allowed, meaning if the letter A was in this first slot, I can use the letter A in the second slot. I have the same number of options. So that's what the repeats allowed is saying. So I have 26 options for here, 26 options for here. Again, letter, 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 followed by digit, 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 digit. So how many options do we have for the number? Well, it could be 0 through 9. How many options is that? It's not 9, it's 10. You have 1, 2, 3, 4, all the way to 9, plus 0 to make the 10th option. So you have 10 options, 10 options, 10 options, 10 options. Taking the product, 26 by 26 by 26 by 10 by 10 by 10 by 10. So to make my life a little nicer, I could compute this on the calculator as 26 raised to the 3rd being multiplied by 10 raised to the 4th. 26 times 26 times 26 is 26 to the 3rd. 10 by 10 by 10 by 10 is 10 to the 4th. So this gives me quite a few options. 1, 7, 5, 7, 6, followed by 1, 2, 3, 4. 1, 2, 3, 4 zeros. So we can accommodate 175 million plus license plate tags. 175, 760, 1, 2, 3. Moment of of truth. Hey, we got it. All right. Let's see. So do recognize that problem number 5. So let's jump to problem number 5. You might read this and think, well, what are my options? So recognize baby Sophia wants to arrange 9 blocks in a row. How many different arrangements can she make? This, again, is still the slot argument. However, it's not as akin to these previous examples. So baby Sophia wants to arrange 9 blocks in a row. So we're going to have an empty slot for each block. So here's our 9 empty slots, and she's going to arrange these particular blocks in an order. So recognize this first block. How many options does she have? Well, she has 9 blocks, so she has 9 options. For this next block, when she places it, how many options does she have? Well, she had 9 blocks originally, and she placed this first one. So for the second placement, she's going to have 8 options. For the third block she's going to place, you probably recognize the pattern. She had 9 blocks to place. She placed 2 of them. That leaves 7 more options for a block to place. And I assume you recognize the pattern that's coming about here. So this is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that will give us the number of arrangements. So this kind of stair-step downward multiplication is used very frequently in counting or combinatorics, and this is equal to 9 factorial. So when you see this factorial, that it looks exactly like an exclamation mark, and what that is a mathematical operation. So if you see something like 9 factorial, that says take 9 and multiply it by 8, by 7, by 6, by 5, all the way down to 1. So something like 4 factorial would equal 4 times 3 times 2 times 1. So my math lab will not let you just simply type in 9 factorial. So we do have to compute this 9 factorial. In most calculators, I believe the TI-83s, under math, so on the TI-83s and the 84s, if you go to math and then scroll over to probability or number possibly, just look around in your math key and you'll see an exclamation mark. On this TI-36X Pro, the factorial is right here. And in fact, that's where all of our combinatoric buttons will be. So there's my 9 factorial. I don't know how well you can see it, but when you do 9 factorial, we get 362,880. So we have 362,880. 362,880. Okay. Check answer, moment of truth. Hey, look at that. We got it. All right. So that is the slot argument. Drop empty slots down to represent particular option or particular things you get to choose, and then inside of the slot fill in the number of options you have for that particular thing you're choosing. All right. So let's go ahead and jump to number 7. All right. So, number 7 is a very nice introduction to these 2 functions I will list out. NPR, NCR. So these are 2 different functions. And essentially, what these do is you select N and you select R, and what it does is it spits out a number. So how do you select N and how do you select R? Well, N is the number of objects for both of these, and then R is the number of objects you want to use. Okay, so let's just negate this explanation and jump into an example. I think it'll become more clear as we work through something. Okay, so a lottery game requires that 5 different numbers are picked from 1 to 12. If someone picks all 5 winning numbers, the person wins 12 million. Complete parts A and B below. So how many ways are there to choose 5 numbers? So the n is the total number of objects we select from. So n is the total number of objects you select from. R is the number of objects that you want. So in this scenario, the total number of objects we're selecting from would be 12. That would be the numbers 1 through 12. We would have 12 objects. In R, in this case, the number of objects that you want, well, we're picking 5 from the 12. So our functions would look like 12p5 and 12c5. Okay, so those are the 2 functions we want to utilize. And these 2 functions are found on your calculator. So, okay. How are these 2 functions different? Well, one of the functions, order, matters. The other function, order, does not matter. So here's how I compartmentalize it. P, I think of the word presidential, so presidential election. Order certainly matters. President, vice president, secretary of state. The order of those selections certainly matters. C, I think of combination pizza. It doesn't matter if your pizza is cheese, pepperoni, jalapenos, or jalapenos, pepperoni, and cheese. It's the same pizza. So, order does not matter. Order does matter. Okay, so to answer question A, how many ways are there to choose 5 numbers if order is not important? So recognize we want to use this one, the NCR. N is 12. We have 12 objects. We're selecting 5 of those objects, and order does not matter. So this is what we want to utilize. On the TI calculators, if you go into math and then probability, you'll find the NPR and the NCR functions. On the TI-36X Pro, it's right on your home screen. So in any case, the TI calculators, you'll want to punch in this value for N first. So you'd go 12, and then find your NCR. There's my NCR. And I'm going to choose 5 of those objects. So I have 792. So this is equal to 792. And we'll go over where that function's coming from in a second. All right, so we got it. The next question, how many ways are there to choose 5 numbers if order does matter? Well, hey, that's going to be 12p5. 12p5. Quite a bit more, 95,040. So 95,040. So recognize quite a bit more. Many more ways if order matters than if order does not matter, which should be expected. The size difference might be unexpected. Quite a bit more ways if order matters. All right, cool, and we got it. So, where does this function come from? So these NPR and NCR ideas. So first, before I forget, if you do not have one of these nice little calculators, you can have access to those functions. Let me open up the Desmos calculator. So go to Desmos. Scientific calculator. I'll make this a little bigger so you can see what I'm searching for. So Desmos scientific calculator. There we go. And then here's the home screen of the Desmos. If you go over to function, you'll see these NPR, NCR functions. And when you type these into the Desmos, so let's do 12p5, you would do 12, comma, 5, right parenthesis. So that would be the 12p5. For the 12c5, similar style formatting, 12, comma, 5, right parenthesis. And then there's those two equations in this very nice, handy Desmos scientific calculator. Wonderful resource. Definitely heavily recommend this outside in the real world. You can punch in equations just how you see them. We have these very nice functions that are embedded into this calculator. It's a fantastic resource. Highly encourage it. So that finishes up this video on the homework 20. I'll post one more video of this following up on this equation. And in fact, you can page through the notes over this counting section to see these two equations and where they come from. They utilize this idea of the factorial. So this idea of the factorial is buried inside of these functions. So we'll go ahead and leave it at that. This should be enough to get you through homework 20. Do take note that everything on this homework is either a slot argument style or an NPR-NCR style solution. So thank you for your attention. I'll see you on the next one.